Okay, so we're solving quadratic equations using the square root method. So I wrote here, recall the factoring method. So if we look at this problem and we want to use the factoring method, we want to make sure the equation is equal to 0. Then we want to factor it. This one's a difference of two perfect squares. So I'm going to have x plus 5, x minus 5. I set each factor equal to 0. I solve the resulting equations. So I'm going to have x is equal to -5 and x is equal to +5. So we could solve this one by using the factoring method, but this particular problem we could also solve by using the square root method. Let's put some procedures for square root method. So let's look at this problem using the square root method. So if I have x squared minus 25 is equal to 0, with the square root method, I don't want the equation equal to 0. What I'm more concerned with is isolating our perfect square variable. So I want to get x squared by itself. So really, I want to move this to the other side. I want to do plus 25 plus 25. I want x squared is equal to 25. And this is square root method procedure. So once I isolate the perfect square variable, I'm going to take the square root. I want to remove this square. So I want to do the inverse operation. The opposite of squaring is square rooting. So I want to take the square root of x squared. Whatever I do to the left side of the equation, I have to do to the right side of the equation. So I have the square root of x squared, which is just x, and the square root of 25, which is just 5. So we simplify it, we get x is equal to 5. And it works, because if I substitute it in, 5 times 5 is 25. But what we have to take into consideration is that -5 times -5 is also 25. So when we solve by using the square root method, when we solve for x, we have to remember our solution could be +5 or -5. We have to be sure to include that plus minus symbol. The solution could either be positive or negative every time we use the square root method. I like this next method, or rather this next example, because x squared minus 8 is not factorable. So I couldn't use the factoring method to solve this one. But I could use the square root method. Right? I could isolate my square, plus 8 plus 8. Oops. So I'm going to have x squared is equal to 8. I want to get rid of my square, so I'm going to take the square root of both sides. So I'm going to have x is equal to plus or minus radical 8. Right after you take the square root, you want to put in that plus minus sign. So we've solved for x. X is equal to plus minus radical 8, which is fine, except for radical 8 isn't in the simplest radical form. This could be simplified a little bit more from what you know about radicals. This could be broken up as 4 times 2. So my answer in simplest radical form would be plus minus 2 rad 2. So let's look at these two examples. This is obviously a quadratic, right? It's a second degree equation. You might first try this one by factoring. There's nothing wrong with that. I'll tell you now, it's not going to work. And then you could move on to using the square root method. In fact, anytime you have one variable like this squared, you could always isolate that x squared and use square root method. So that's one telltale sign. So I would do plus 7 plus 7. I'm going to get 2x squared is equal to, what is this, negative 8. I want to get x squared by itself, so I'm going to divide both sides by 2. So I have x is equal to, x squared is equal to negative 4. I want to get x by itself. I want to get rid of this square, so I'm going to take the square root of both sides. So I'm going to have x is equal to plus or minus the square root of negative 4. Well, I know the square root of negative 4. First of all, it's a negative under a radical. This could be simplified, right? This is really 4 times negative 1. So it looks like my answer for x is going to be plus or minus, that's going to be 2i. Square root of 4 is 2, and the square root of negative 1 is I. My answer here is x is equal to plus or minus 2i. Don't get ahead of yourself with this one. My square value is this whole binomial. So let's isolate this whole binomial. I'm going to subtract 4 from both sides of the equation. So I'm going to have 8x minus 3 squared is equal to 5. I want to get rid of this. I want to get rid of this square. So I want to square root both sides of the equation. The square root of a square cancel each other out. So I'm going to have 8x minus 3 is equal to plus or minus rad 5. I no longer have I do have a radical still. My objective is to isolate x. So I'm going to add 3 to both sides. So I have 8x is equal to, I can't combine these, they're unlike, right? I can only combine radicals with radicals. So I could write this as 3 plus or minus radical 5. I still haven't gotten my x by itself. So I have to divide both sides by 8. So I have x is equal to 3 plus or minus rad 5 over 8. The end. You could also write it as x is equal to 3/8 plus rad 5 over 8, but there's really no reason to do that. That would be your answer. Let's try some more. Let's look at these two examples. We want to solve these using square root method. I'll give you a minute. So in this case, the square binomial is already isolated. So I could take the square root of both sides. So I would have 2x plus 8 is equal to plus or minus rad 27. I want to isolate my x, so I'm going to subtract 8 from both sides of the equation. I'll have 2x is equal to negative 8 plus or minus rad 27, and divide both sides by 2. I get x is equal to negative 8 plus or minus rad 27 all over 2. But rad 27 could be simplified. I know rad 27 is really rad 9 times rad 3. So really my final answer in simplest radical form is going to be negative 8 plus or minus square root of 9 is 3, rad 3 over 2. That's it. If all three of these had a common multiple, so for example, if this was a 6 here or a 4, we would be able to simplify it. If this value, and this value have a common factor, this expression can be reduced. But in this case, it doesn't. Some might write this as negative 8 over 2 plus or minus 3 over 3 over 2. And then that could be simplified as negative 4 plus 3 over 2 rad 2. But that doesn't look any simpler. It actually looks worse to me. So I would stay with this. In this next example, we want to get our perfect square binomial by itself. So I'm going to subtract 1 from both sides. So I'm going to have 5x minus 2 is equal to 9. And this is squared. Way out of focus. I'm going to take the square root of both sides. So I'm going to have 5x minus 2. My square root cancels out my square, equals plus or minus 3. I add 2 to both sides. So I'm going to have 5x is equal to 2 plus or minus 3 divided by 5. So I have x is equal to 2 plus or minus 3 all over 5, which could be simplified because I could add or subtract the top. Really, I have two solutions. I have x is equal to 2 plus 3 over 5, and I have x is equal to 2 minus 3 over 5. There's two different stories here. There's two answers to every one of these quadratics. So in this case, this looks like it's going to be 5 over 5, which is 1. And in this case, it looks like negative 1 over 5, which is 1/5. Try this last example. I'll give you a second. So now I want to isolate our x. I'm going to do plus 1 plus 1. So I have 4x is equal to 1 plus or minus rad 12. Divide by 4, divide by 4. So x is equal to 1 plus or minus. I'm running out of room, so I'm going to simplify this. 12 is rad 4 times 3, which is 2 rad 3. All over 4. Right, we all agree. Rad 12 could be broken up as rad 4 times rad 3. So it's 2 rad 3. So my final answer looks like this. I would have liked this better if I made that a 6 or a 2, because then if that was a, if we had, I don't know, 6 plus 2 rad 3 over 4, well, then we could simplify all of these by 2. We could divide out a 2. We'd have 3 plus or minus 1 rad 3 all over 2. I could divide out a 2 from each one of these if it had a common multiple of 2. And the reason I could do that, just because I'm keep talking here, is because to simplify, we could factor out a GCF. They would have a GCF of 2 here. You would have a 2 on the outside, and you'd have 3 plus rad 3 on the inside. You'd have 4 on the bottom, and then those would cancel out, and we'd end up with this. If this was the scenario, but it's not. So that's your answer. The end.